Hello viewers, welcome to iTech Combo. In this tutorial we are going to learn about cost function and about gradient descent method. So let's say there are some data and I will be finding the best fit line out there. So for what should be the property of best fit line? So it will be near to all the datas comparative to the any other line drawn out there. So how can we find this? So let's draw some lines. So this can be a line, this can be a line, this can be a line, this can be a line. So anyone can be a line. So how can we know that this line is the best one? And so for measuring this property, I will need to take help of cost function. So what is cost function? So cost function actually is the sum of all the error out there. So what is error out there? So let's draw some lines out there, and you can see this is a line, and this point out there will have y. This point out there will have y. Okay, I need to wipe this out. So this point, actually this point is y head, and this point out there is the y. And if I give a subscript of I out there, for I number of points, it will have this I number of yi and I number of y head I. So to find the total error, so let's say I want to find the total error out there. So what should I do? I should let's say y minus y head. So this is for a single point. So give I out there and I out there. Let's say I have n number of data. So from I equal to 1 to for 1 to n, I will have all the errors out there, and these collections of error is known as the cost. So let's give the name of the function as j. Now what is y head I? So this is basically this line. So since a straight line, we can define a straight line. So let's draw another thing. A straight line. So we'll have a equation like this one: y head equal theta 1 x plus theta 2. So for this straight line, we don't know what should be the value of theta 1 and theta 2. So how can we find this theta 1 and theta 2? And to find this theta 1 and theta 2, initially we will take any value, arbitrary any value I will take, and then I will take the help of gradient descent method. So let's see what is gradient descent method. Let's say the cost function out there j will be like this one. Let's say, so let's take a point here in this axis we have plotted j, and in this axis we have plotted theta. So let's say let's take any point out there, any arbitrary point of theta. So I'll be taking a point out there. So point out there, let's take a point out there. So this is the arbitrary point of theta. Now let's see this equation out there. Let's see theta 1 equal to theta 1 minus alpha partial differentiation of j of theta 1 with respect to theta 1. So if we if we differentiate this j with respect to theta, at this point we will have a negative slope. So let's see. So I will have a negative value out there, and alpha is a positive, so ultimately I will have a negative, and there is another negative. So negative will produce a positive number. So positive number and another will be plus with theta 1. Ultimately this point out there will go forward, and again if I do the same thing from this point, it will go forward, and it will go forward, it will go forward, it will go forward, and ultimately it will reach this minimum point where the cost is minimum, which is the desired thing. Let's say I have taken the point at this point. So at this point, if I differentiate, differentiate at that point, I will have a positive value. So positive value multiplied with a positive number will produce positive, and subtracted there, so it will decrease. The final theta 1 will be decreased, so the theta 1 go in that direction, so ultimately it will reach out there. And I can see that there is a new thing which is alpha. So what is alpha out there? So alpha is basically a hyperparameter. So what is a hyperparameter? Hyperparameter is thing which a programmer need to define what should be the value of alpha hyperparameter by computation. So if we see, let's say for theta 1 theta 2, I will have a 3D graph out there. So at this point, so if I differentiate, it will go there, and ultimately it will reach at this point. So I will have the minimum. In this way, I have calculated the best fit line and which have the minimum cost, and this method is called gradient descent method, and this is one of the method of optimization. So in the next tutorial we are going to implement this gradient descent method through Python sketch. See you then. Up to then, have a good day. Thank you.